We can see from the general form for a complex number, a plus bi, that complex numbers have both a real part, which comes from the number a, and an imaginary part, which comes from this part, bi. Remember, a and b are just real numbers here, but this part bi is an imaginary part because of the I. And we can talk about the size of a real number by plotting it on a simple number line, because there's just a linear progression of numbers, higher and lower than 0. Because complex numbers have these two parts, though, the real and the imaginary, we can't plot them in a one-dimensional way. Instead, we need to plot them on a two-dimensional axis, similar to the Cartesian coordinate plane we've been working with. This fulfills a very different purpose, though. We're not graphing equations on here. We're not relating variables x and y to one another. We're just graphing numbers that are written in this form. What we do is we label this horizontal axis on our plane the real axis, and we say that the vertical axis is the imaginary axis. So for any complex number written in the form a plus bi, we can instead write it as the point a comma b on this coordinate plane. So the horizontal coordinate comes from the value of the real part, and the vertical coordinate comes from the coefficient of the imaginary part. Let's look at an example. So if I plot the point 4, 6 on our set of axes, this translates into the complex number 4 plus 6i. That's what's being depicted by this point on this plane. Let's say we want to express -7 plus 2i. Then we go to -7 horizontally, and then up 2. So on this plane, we can graph any number written in this form.